Good. When we were here yesterday, we were dealing with factorizing by grouping. So we're going to do one of the exercises that you were given on the trials. So in other words, you know that in the first pair, in the first pair, we have that 4 is common. Was the highest common factor for 12 and 28. We have x is common. Whenever you factorizing, of course, you insert brackets. So you're going to insert parentheses. Please note. And from there now we can see how many 4s are in 12. 4 into 12 is 3. And x into xy is y. And how many 4s are in negative 28? Negative 7, and x into x is, they're going to cancel out and give you 1. 7 times 1 is 7. What's in this parentheses goes into this parentheses. We're going to have 3y minus 7. And the question that, of course, you're going to ask yourself now is, what time this in the second parentheses gives us the second pair of terms. So in order, you're going to see that it is 5. Well, what type of 5? A negative 5. Is that okay? From there, we're going to factorize one more time. So we're going to have 3y minus 7 times 4x minus 5. And it doesn't matter if you write 4x minus 5 first and 3y minus 7 afterwards. It doesn't matter, the result is going to be the same. Now for today, we have these systems existing here, and you're being asked to factorize. So we have the color codes to help us. So the first thing that you're going to note is that for 21, 14, and 7, that the HCF is 7 from your 7 times table. And with the variables, the highest common factor for a cubed, a to the 4th, and a to the 6th is the one with the lowest exponent. So please note that. So that's a cubed, right? And in the b's now, the highest common factor for b to the 7th, b to the 9th, and b to the 11th is the one with the less exponent again. So we're going to have that. Because we factorizing, we're going to insert brackets. So let's go and try that. We're going to go and divide and multiply, divide and multiply. So let's go and try that and see what happens until we exhaust the exercise. So let's go. How many 7s are in 21? 3 of them, right? All right. What's a cube into itself? 1. I'm going to write the 1. Are you seeing it? It's invisible, huh? Okay. And what is b to the 7th into b to the 7th? I write the 1. Are you seeing the 1? Good. You're not seeing the 1, so that's cool. In other words, it's just 3 is going to go there because 7a cubed b to the 7 times 3 is going to give back the first term. Let's go and see what we're going to have in the second one now. How many 7s are there in 14? That's 2, right? 2, 2. And what is a cubed into a to the 4th? That's a, because I'm going to try to color code that. That's a, because there's a 1 here, and 3 plus 1 is 4. Remember your indices. And what is b to the 7th into b to the 9th? In other words, 7 plus what gives 9? 2. So please note what's going on in the color coding approach. Let's go to the final term now, which is how many 7s are in total 5? That is 5. That's 5. And what is a cubed into a to the 6? That's going to be a cubed, because 3 plus 3, not 3 times 3. 3 plus 3, whenever you multiply and the bases are the same, you always add the exponents. So you can add it in a way to check back. And from there, we're going to have, we're going to the black now, b to the 7th into b to the 11th. 7, and how much more is 11? 4. And that's the end of that system. And if you want to distribute, check and see if you're going to get back the same result, you'll more than likely get back the same result. So you can do that. So this is when there's a whole number coefficient. What about when the coefficient is a fraction? The approach is the same, but in this case, we're going to focus primarily on the denominator. So we're going to have what is common. We're going to have a 1 over 3. And for the g's, the highest common factor is being determined by the lowest exponents. So we're going to have g to the fifth. And from there, we're going to go open parentheses. We're going to open up parentheses, see what happens. Good. So in other words, let's go and work our denominators in particular. Put back this one. Since 1 into 1 is 1, how many 3's are in 27? 9. And what is g to the fifth divided by g to the fifth? 1. Could I put a 1? Are you seeing it? Okay. I didn't write you the market because 1/9 times 1 is 1/9. And from there, we are going to go and continue the process here with what is 1/3 into itself? 1. And what is g to the fifth into g to the 11th? That's g to the sixth, because 5 plus 6 gives us 11. So please note what has happened there. And this is how basically you would deal with respective systems looking like this here in factorization. So what you're going to do is try one and try two, and see you in my next video. God bless you.